So welcome to week number 11 of Visually Understanding Quantum Computing. We have already covered a lot of stuff in the previous 10 weeks. And if you're new here, you can just at least start with the very first video. Just go through the first video. It's almost 4 minutes long. And a video will help you to understand what this playlist is about. And it will also help you to get this little GUI app for yourself so that you can follow along with this video at least, or you can do some crazy experiments with this app. So with that said, today here in week number 11 of Visually Understanding Quantum Computing, we will just visualize some of the important quantum computing identities. They are really famous ones, and I think it's good to know about them. Uh, and if you're new here, it will also help you to understand how quantum glasses, this little app of ours, can be really helpful to visually understand quantum computing. So, with that said, let's start our journey for this week. So, our very first identity is here displayed in the top left of your screen, which is HZH equal to X, where H is the Hadamard gate, Z is the poly Z gate, and X is the poly X gate or quantum NOT gate. So let's first visualize the right hand side of this identity, which is X. So let's see what the effect it has. Uh, just notice here this little X that denotes the gate whose effect you are seeing right now, and this is the effect that it has. So from 0 ket, the uh, state was moved to 1 ket of our quantum qubit or quantum system. All right. So let's now visualize the left hand side of this identity. So we will have H, then Z, then H, and let's see. And you can see that the end results for both of the LHS as well RHS were the same. It ended up on the 1 kit. So we can conclude that both of them are identities, and we have visually seen how it works. So let's move on to the next one. So our identity number 2 is again displayed on your screen, which is H square equal to identity, which is nothing but Hadamard applied consecutively results into identity. That means it has no effect when you apply Hadamard consecutively. All right. So let's visualize that. Two Hadamards, and let's see. So it is started from here, 0 ket. All right. So it means that if it has no effect, then after the operation, the state vector should again just end up in the 0 ket state. All right. So let's see what happens. And I think it's already in the second phase, and that's it. It's done, and you can see the state and the final state again was 0 ket. So it just means that applying these two consecutively won't have any effect. And if you want to play around more with this, you can just get yourself quantum glasses and uh, do some crazy experiments with it. But for now, let's move on to the identity number 3. So our identity number 3 is y equal to IXZ, where y, x, and z, all of them are just polygates, and I is iota from complex numbers. All right. So let's first visualize the LHS of this identity. See, it's having the effect, and if you have gone through the visual understanding quantum computing playlist, you know that the answer is 1 ket. And now let's move to the RHS part. Note that iota is important, but for the mathematical part. But here can just have x and z operators. All right, and let's visualize and see what happens. And this is a little interesting visualization. So you can just try to pause and just ask yourself what would happen, and that's it. The visualization is done, and if you see, Z had no effect. And if you have attended the previous weeks of this playlist, you must know the answer why Z did not affect when the state was one cat. All right. So I think we are done with the third identity. Now let's move on to the fourth identity and the final identity for this video. So the final identity for the week is HXH equal to Z, and let's apply Z. Although we know that Z will have no effect on 0 cat, so it will just stand on 0 cat, and it will have no effect. All right. So what we can do is that let's first apply a header mart, and then we will apply Z, so we can at least see some effect. All right. So first you can see here H written here, so it just denotes that this is the effect for the header mart gate, and the Z part now comes. All right. So let's see where it stops, and it will stop there. All right. So this is the state. Okay. So from here, I know coinciding with X. All right. So since we have applied header mart on the right part of this identity, we shall also apply it on the left hand side. So now what we'll do is that the additional header mart and HXH. All right. And after this visualization, what we should get is just simply the that minus cat state, or the state that was just directly coinciding. Uh, okay, I just showed you the one. So let's see what happens. So as you can see that we just got back to that state after applying all of this operation. So it just means that the LHS was indeed equal to RHS, and I think we already visualized all of the four quantum computing identities. So this is that marks the end for this week, but the journey of visually understanding quantum computing is far from over. And next week we will again be studying some really awesome gates. And until then, take care.